Welcome. So there's two questions here. We're going to do the top one. It says, given that vector A equals minus 3i plus 2j minus 4k, and vector B equals plus 5 minus 2j plus 1k, determine A cross B. Remember, there's two types of ways I can multiply vectors together. I can multiply two vectors together and get a scalar product, which is symbolized by a dot, and that's called a dot product colloquially. And I can multiply the two vectors together and get a vector product, and that is symbolized by a cross, and it's called a cross product colloquially, and that's what we're doing today. A good example of using a dot product would be using force and displacement to determine work, and a good example of using a cross product would be using force and displacement to find torque. So we're doing the latter. We're trying to use a cross product. And to work these out, there's various different schemas that you'll be shown. This is the one that I was shown when I was a student, and so it's the one that I've used pretty much ever since. My method involves making up a grid. So I have an I, a J, and a K pattern. The order now matters, and it is A cross B. So I must put my vector A down first, and this will be minus 3, this will be plus 2, and this will be minus 4. So I put down my coefficients in order. And then for vector B, B goes underneath, so it's going to be plus 5, a minus 2, and a plus 1. So there's my grid, and I'm going to use that to find my I, J, and K term. I wish you could see my fingers, because at this point, you know, my finger goes over the I column, and I can't really do that. So what I'm going to do is I'm going to use that to show the effect. So my finger is over the I column, and then what I'm going to do is I'm going to turn around and say this is plus, and I'm going to cross multiply. So it's going to be plus 2 times plus 1 minus 4 times minus 2. And that would give me my I coefficient. Okay. So then I just double check. Plus 2, and then yes, negative sign starts with a plus. Yes. And then let's get rid of that guy. And then now let's cover over the J. When you want to find the J, you cover the J over. I know it seems ironic, but that's what we do. Now, the second thing is a little piece of memorization. This is a negative sign. And we go minus 3 times plus 1 minus 4 times plus 5. And that would be J. Let me double check. So I did that, and then I did that, and I subtracted them, but I put a negative sign in front, and that looks right. And now I want to find my K, so I'm putting my finger over the K. And now I have a positive. It goes positive, negative, positive. Now I have minus 3 times minus 2, subtract, plus 5 plus 2. This would be K. And let me double check that again. So it's minus 3 and minus 2. And plus 5 and plus 2. I subtracted them and I put a positive in front. Good. So that looks reasonable. Bring that back there. And then let's see what I get. That's going to be 2 minus, that's positive 8. 2 minus 8 is minus 6, minus 6, minus 6i. And then this one is minus 3, minus 20. Minus 3 plus 20 is plus 17, but there's a negative sign there, so that's minus 17j. And then for my third term, I'm going to have plus 6 minus plus 10. Plus 6 minus plus 10 is going to be minus 4 positive. Minus 4k. So to write this down nicely, I'd say A crossed with B, vector A crossed with vector B is equal to minus 6i minus 17j minus 4k. And frankly, that should have some units, most of the time anyway. If this was a force and that was a displacement, this would be in Newton meters. I can't tell you how often students will give me an IJK vector and then just ignore units. And I'm not sure why that is. It's maybe they're so focused on the IJK they forget about units, or maybe there's something mentally where they write down letters of one kind so they don't worry about letters of another kind. But if it is a cross product where you're crossing vectors that have some physicality to them, then there should be units there, and you should be careful to mark down your units. So there we have it. You may have been taught a different way in math, and by all means use it, but if you have not been taught a different way in math, then this is a way of getting the correct answer. Find a way and stick to it. It comes up very, very often from now on. There's so many parts of physics make use of dot products, and here make use of cross products. So there we have it.